Welcome to seminar. Thanks for coming. I'm really happy to have Jeppe Kjaersgaard here. He's a scientist at the MDA who I think has collaborated with a lot of people in this room. If not, you should start. He's very easy to work with and thoughtful and good perspectives on a lot of issues around water and agriculture in Minnesota. I think you do have adjunct appointment at BBE, right? Yep. And he's going to talk to us today about, why is it not all happening at the same time? There. He's going to talk to us today about nitrate inhibitors and polymer-coated urea. He's been involved in all of our nutrient reduction efforts, right, across the state. I want to say that our next seminar is October 8th, and it's Yao Yi Chiang, who's going to talk about fine-scale soil mapping. I think it's a guest in the Dolinsky lab who's going to present that week. So we'll see you again in a couple weeks after this, but thank you for now, Jeppe.
All right, thanks, Anna. Thanks for that introduction, and thank you for having me, and thank you all for coming. I really appreciate it. Again, my name is Jeppe Kjaersgaard. I'm a research scientist with the Minnesota Department of Agriculture. I am an agronomist by training and have been in my current role at the department for 11 years now already. Today, I'm going to talk about an activity that we have had over the last several months, 6 months, related to inhibitors of polymer-coated urea. And so I'm going to start out by talking about that, but then Anna said, hey, would you mind just mentioning the weather station, or weather network expansion that we have underway? So at the end of the presentation here, I'm going to talk a little bit, or just give an update on that. It is unrelated to the inhibitors, but I'm happy to talk about that also. And so really three things I was hoping to cover today. First, talk a little bit about the background for the work that I've been doing, or we've been doing at the agency related to inhibitors of polymer-coated urea, or PCU. And then again, as I said, just give a little bit of an update on where we're at with the expansion of the Minnesota Ag Weather Network. So at the department, one of the things we are working on, we are implementing a rule that was passed back in 2019 called the Groundwater Protection Rule. There are a lot of aspects related to that, but one of them is that it applies to drinking water supply management areas, what we call DRISMAs, where the community wells have high levels of nitrate. And so a community well, that is typically where like a town or city, could also be other rural communities, rural schools, churches, and such.
Pardon me, I apparently didn't get the Zoom here.
All right.
Just got a text from somebody that's not coming around. Okay.
Or they were seeing something else.
I don't know what they were seeing. Where is our Zoom window? Is what I can't find. There we go.
It's the other one. It's the other one.
Okay. How are we doing now, Zoom people?
Looks great.
Thank you for answering.
Terrific. Awesome. We'll keep rolling then. And so the thing with community water suppliers is that they are not allowed to send service water out to the consumers that has nitrate concentration above 10 milligrams per liter. There are several communities in the state at the present time that are getting close to the 10 milligrams per liter threshold. Those are the ones we term level 2 communities. Those are the ones that drink water supply management areas where the nitrate concentration in that in the well water has exceeded 8 milligrams per liter at any point over the last 10 years, or is projected to exceed 10 milligrams per liter within the next 10 years. And so they are, many of them are not quite at 10 yet, but they're getting pretty close. And we can compare that to sort of the background information on nitrate concentrations. We typically consider that being in that around 2 to 3 milligrams per liter. And so we do at the current time, we have 23 communities across the state that is in this level 2 category. And so those are all the communities that are listed over on the map over there on the right. So the red towns and communities are the ones that we keep an higher. You'll notice that some of them are relatively small, but there's some of them that are pretty sizable. For example, we have the Hastings just in Dakota County over here, Cold Spring, Glenwood, Burndale, Perham are all relatively significant communities with thousands of people, if not tens of thousands of people in some of them, in the case of Hastings. So it is an important something that we need to look at. Now, I'm just first going to talk a little bit about when this term drinking water supply management area, or DWSMA, what that is. And that's what is shown on this graphic over here. This is Verndale. I don't know if anyone is familiar with it. That's Highway 10 that kind of runs diagonal to the image over here. They have two city wells. That's the two starters up here. And then to figure out where does the water that is being pumped by those wells come from. The Minnesota Department of Health, they do groundwater modeling, and they determine what is called 10-year time of travel. And that is that area within the blue polygon on this map for each well. So that is the area where the water is coming from for the water that's being pumped out the next 10 years. But they that's of course, this doesn't follow any kind of geographic features on the surface. So what the Department of Health does is they square those polygons off into another shape that kind of follows roads, field boundaries, or other kind of features across the landscape. So it is more clear what that area that needs to be protected is. The reason I'm talking about this is that what we're working on when we implement this, the activities I'll talk about in a little bit as part of this groundwater protection rule, it applies to the land that is within the green area. And again, this green area in the case of Verndale, but they are similar drinking water supply management areas for all public water systems in the state. So it's this land, in most cases ag land, that is within those areas that we're talking about. What we do at the department, I'm jumping past a lot of detail here, but one of the things, the main things we do is that we form what we call local advisory teams within each DWSMA. And so that is made up of farmers and their agronomists that we meet with to discuss the groundwater protection rule, to discuss the nitrogen concentrations in the water, and also talk about, well, what are some of the sources of that nitrogen. We base that on, among other things, field measurements, and we do have 3 computer modelers on our team that collects information for each DWSMA, and then run computer modeling and scenario analysis to determine what are the key sources of that nitrogen, and what are some of the scenarios that could be changed to reduce those nitrate leaching losses. And then, as part of those discussions, is to develop what we call nitrogen fertilizer BMP lists. And now we're getting close to the inhibitors, because these nitrogen fertilizer BMP lists, they are based on nitrogen fertilizer best management practices here from the University of Minnesota. And the current ones are the ones that are shown on this figure here, the green bulletins, as we typically call them, that lists nitrogen fertilizer BMPs for different regions of the state. The university is currently working on updating these, but these are the ones we currently have. We take those BMPs, and based on the discussions we have with the farmers and agronomists in each DWSMA, we develop BMP lists for each DWSMA. So those are the practices we've been talking to the farmers and agronomists about, saying, well, what is reasonable, and what would you be willing to change in your crop production, such as reducing nitrogen fertilizer rates, or split application of nitrogen fertilizer, or could even be putting in cover crops or other things, though that's not a BMP. And that is all written down in those BMP lists for each DWSMA, and then they'll be published, and then that the farmers farming within each DWSMA will then have to follow those DWSMA specific BMPs. One of the some of these BMPs, they mention inhibitors and polymer-coated ureas, or PCUs, or the product ESN in particular. And I've just listed a few of them of what the exact wording is. And so there's this one here that talks about the second sentence: use a nitrification inhibitor with early side-raised nitrogen applied to these soils. There's another one from another region, use a nitrogen stabilizer insert. Notice that there's a little bit of a difference in inhibitor stabilizer. Sometimes there's talk about actual products. Other times it's more just a broad mentioning of the type of products that are out there.
I'm sorry, Jeppe.
That is no problem.
We are still not advancing slides on Zoom.
Oh,
So
if I need to grab a pen or a marker, do it on the whiteboard instead.
I guess so. I think that's what I was doing before. And all right. Somebody tell me if these are moving online.
Not that I can see.
That is weird. Any other ideas, guys? Oh, I see we're in Zoom online. That's why everything looks different. It's like it doesn't want me to share anything that's not online also. Right, we still have this.
When you share the screen, could you just like share exactly what your screen sees?
Yeah,
I know PowerPoint can be funny.
I've done this particular move before, but let's see how it looks this time. What do you guys see? Is it moving online?
Yes. Yes.
Okay. And now, but we're not seeing it in presentation mode. So now is it moving?
No.
Okay. What if we do it this way, Eva?
If they can see that, you just run it down.
See, how do I hide this?
That's
You
fine.
live with this?
Yeah. That's
Okay.
fine. That's no problem. All right. Okay, yeah, that works. Perfect. All right. So yes, yep. All right. So we're just talking about the different BMPs that refers to inhibitors, stabilizers. There's one that relates to ESN, so polymer coated urea. Other BMPs talk about specific products, in this case, agrotane and insert, and then there's a nitrification inhibitor again. So there is a little bit of well, there's a different terminology that's used. That's not a complete consistency across all bulletins there, that coupled with that, when you look across the products that are out there, especially when we talk about inhibitors, whether it's urease or nitrification inhibitors, there are a lot of products in the marketplace. Some of them have been around for a long time. We are seeing many that are coming online. Many of the ones have had their active ingredients have been tested by third-party or through third-party research, whether at universities, including here at the U of M or other places. But we're also seeing others that have not. Some of the newer active ingredients that are coming out might not have tested. Also, when you look at the labels for these different products, that some of them are very good at spelling out exactly what's in it, what's the active ingredient, what's the percent of it, and it provides a lot of detail. Other products does not, and that makes it difficult for both from us from the NADC standpoint, but certainly also for the farmers when they are out, talk to their agronomists, make decisions about their nitrogen fertilizer management, of whether they should use an inhibitor or not. That they may look at a product or be sold a product that they have no opportunity to really understand what is in that product, because the label doesn't fully spell out what's in those products. And also, I think it's safe to say that for many of these products, especially the newer ones, that what we call the marketing appear to be ahead of the science, meaning that their salespeople are maybe a little ahead of the scientists within those companies. And just as one example, and I'm not, whoops, that one, as an example of one such product, And I'm not going to say which one it is, but when you look at it for their active ingredients, so they say, well, what's actually in this product? Well, they just say it has NVPT, which is a urease inhibitor, but then copolymers, alcohols, and emulsifiers, 100%. So it's nice to see that there's 100% in the product, but you can't see how much of each ingredient that's in there. So it's really a disservice, I think, for the farmers or agronomists, because you can't really see what's in those products. And so because of that, both to help farmers make decisions about the nitrogen fertilizer and that they get something for the money they spend, but also for the purposes of when farmers are using inhibitors in the drismas for water protection, that we are actually getting a water quality benefit from their investment in using inhibitors. So therefore, we are evaluating inhibitors and polymer-coated urea, ESN, to determine if they qualify for use in drismas with published nitrogen fertilizer BMPs. So in essence saying, if a farmer in one of those drismas is using an inhibitor, we have made a list of products that we have reviewed and deemed acceptable, that there is enough evidence showing that will have a positive impact. It is a little difficult making this evaluation, of course, because there are a lot of factors that impacts the efficiency of inhibitors, and I've listed some of them here. Not least the temperature and the moisture content has a big impact on how efficient these different inhibitors are. In some cases, also the amount of residue cover, especially when we talk about urease inhibitors, is pretty important also. And so it's difficult to draw a hard line and say, well, no, this product works and this one doesn't, because many products will work most of the time and other products probably don't work most of the time. So it's kind of find a little bit of that sliding scale, finding out, well, which products can we say with some enough confidence that they will work under most conditions here in Minnesota. And so what we're looking at is specifically two primary things. First, we are evaluating each product for the active ingredient. So going back and looking at it saying, has this particular active ingredient been shown to be efficient or inhibit either nitrification or urease inhibitor, or in the case of polymer-coated urea, delay nitrogen release. So that's one thing. The other one is we're looking at is what is the application rate? Is there enough, if you follow the label, is there enough of this product being applied either to the fertilizer, to the soil, to have a benefit? We are seeing some products that has an active ingredient that has been found to work, but the application rate is so small that you're likely not going to see any benefit from it. So those are the two things we're looking at, and then we're developing tables of acceptable products that we are just about to publish now on our website. All right, so that was sort of the background for why we are looking at inhibitors and polymer-coated urea. And so now I'm going to talk a little bit or talk more about the process and where we are at with developing those tables. And so it all comes back to the nitrogen cycle, of course. Big picture here, we are looking at nitrogen from fertilizers, urea, nitrate, ammonia. It could also be ammonia with breakdown from organic matter through the various processes, leading to the conversion of that nitrogen into the form of nitrate. The primary nitrogen loss pathways from soil, there are really two main things that we can address or target when we talk about inhibitors. One is volatilization of ammonia, and so that is typically from if ammonia, an improper ammonia application, for example, anhydrous ammonia being applied either in dry soil or too close to the surface, urea that's left on the soil surface, and then the ammonia, nitrogen in form of ammonia can volatilize off that. And those losses are typically within the first few days of application. Other losses relate to nitrate. So one is typically on coarser texture soil with nitrate leaching. That is when we have a downward water flow. And then the third one, that is the conversion of nitrate to nitrogen gas through denitrification. And both those situations, if we have an excess amount of water in the soil, the risk of the green losses here, of course, they are higher in the spring when we typically have more water in the soil, but it can happen throughout the growing season. And so there are these different products, broadly, we can call them enhanced efficiency fertilizers, that can help reduce some of these losses. There are sort of two broad categories, or three, I guess I've listed here, of categories for enhanced efficiency fertilizers. One relates to slow or controlled release fertilizers. And so that is where the fertilizer itself has been modified one way or another to slow the availability of nitrogen and the exposure to loss. And then there are inhibitors, which are chemical additives that can help reduce the loss by slowing the conversion to forms that are susceptible to loss. We do have others as well, sort of other biological or chemical processes, bactericides, fumigation, change in pH, or other things that can help keep nitrogen in a form that's less susceptible to loss. I'm not going to talk about those today, but I just want to recognize that there are those other technologies also. So now looking first at controlled release fertilizers, as well as controlled release fertilizers. And there is one product that we've looked at already. The primary one, polymer-coated urea. The primary one we have around here is ESN, environmental sensitive nitrogen. That has been around for a long time. A lot of research has been taking place, and currently is taking place also here at the U related to ESN. But there are a few other brands as well. Polyon, I'm aware of it. I don't know if it's ever been in Minnesota. Too expensive. Okay. And I know there's some other brands also in turf and horticulture that I'm not even aware of. Then there's another one, sulfur-coated poly is the one I am aware of. Is there?
I don't think we'll need to.
Do I just need to slip back there? No.
I think that one.
All right. Try that right there. All right. Of course, the difference with ESN is that it's a polymer coating. The way it works is that water will move. It acts as a semi-permeable membrane. Water will move through that membrane, dissolve the nitrogen or the urea on the inside, and it'll move out through via diffusion. Sulfur-coated polyester, that is also a membrane, but that membrane has to be either broken down by bacteria, or it has to break through mechanical action or something for the nitrogen to ooze out of the prill of the coating, if you will. But ESN is by far the most common one, and that's the one that we've been looking at. Also, here, I want to recognize there are other products that sort of falls in this category. I've listed them over there on the right. I think my understanding is they can be used. They're more expensive. They might be used in, say, golf courses, other places where these can be crushed into a powder, so you can use them on like the green or whatever on the golf course. Whereas the polymer-coated ones, you can't crush those; then they're just regular urea. That the coating has to be intact. But so there are a few other products over there, but they are less relevant for agricultural purposes. So ESN, environmental sensitive nitrogen, again, urea prill with a polymer coating on it. And it has been shown, there's been a lot of research showing that it effectively delays the release of urea. One of the things that we run into here is that when we look at the nitrogen fertilizer BMPs here from the university, most of the research in those bulletins were based on 100% ESN application, which is uncommon. Farmers will typically blend ESN with urea in some ratio. And so we have gone back and looked at more recent research, especially here from the research within this department here at the university. Based on that research, conversations with faculty and with the researchers, that we have found that if there is a minimum of 30% of the total N is from ESN in a blend, that will meet the requirements. So that means that if there is a BMP that requires the use or the application of ESN, we will be moving forward with that 30% of total N requirement. So this falls more in line with what farmers are typically doing. It's pretty common to use, say, a third ESN, 2/3 urea in a blend. So they fall within that with this requirement. Okay, so that was what we've looked at with slow controlled release fertilizers. Now we'll move on and talk about inhibitors. So when we talk about inhibitors, there are two classes that we usually look at. One is urease inhibitors, and those are inhibitors that slows the conversion of urea to ammonia. And then the other one is nitrification inhibitors that slows the conversion of ammonia to nitrate. So with the urease inhibitors, that is primarily to control volatilization. And for the nitrification inhibitors, that is to delay the conversion from ammonia to nitrate. For urease inhibitors, there are a number of active ingredients that are available in the marketplace. The by far most common one is the one called NBPT, and I'm going to show a list of some of those products on a later slide. There are a few other active ingredients. One that's come out more recently is duramide, and there's the product I'm aware of. That one is called Anvol, and then we have various thiosulfates. For the nitrification inhibitors, the most common ones are nitropyrin. That is the trade names are Instinct, Enserve. Vindicate is one that is used in California, I believe, on some of the fruit, nut trees, and that kind of stuff out there. But the ones that are on the market here, there's generations of Instinct and Enserve. And then we have DCD, and I have a list of some of those later as well. There's a newer product that has come out somewhat recently, pronitrodine. That those trade names are Centuro, and nitrate bullet is a newer product there as well. Then we have a number of products that are combinations that has both active ingredients, so they can have both urease and nitrification inhibiting properties. And I've listed some of those here: Super U, NS Pro, Agrotane, and there are many others as well. But so those are we focused on NBPT for urease inhibitors, nitropyrin, and DCD for the nitrification inhibitors. When we talk about the urease inhibitors, that is this active ingredient NBPT that ties up the urease enzyme. Urease is an enzyme that facilitates the conversion from nitrogen form of urea to carbon dioxide and ammonia. And so again, it's that enzyme that is being inhibited, and that delays the hydrolysis of the conversion into ammonia. And again, ammonia, of course, is a gas form that can volatilize. So going back, looking at the data or studies that have looked at, well, what is the efficacy of NBPT? And it has been shown widely that it delays the hydrolysis of urea. And there are just some of the studies I was looking at. There is the Nutrient Star literature review that has a large number of publications they reviewed. Dave Franzen of the NDSU has some publications, and then Dan and Fabian here at the U has done some studies as well. When we talk about NBPT, no one has really gone out and said, well, what is the minimum application rate? So we have determined, does the active ingredient work? Yes, it does. Then the second part is, well, what is the minimum application rate? And we haven't found anyone that have made recommendations for, well, what is the minimum application rate? How much of this active ingredient is needed to have a benefit under most conditions? So we went back and looked at an approach that Roberts et al. Out of Arkansas did, and based on our literature review, we established a threshold for the application rate. And so what we are moving forward with is that there must be at least 1.3 pounds of NBPT per ton urea, for urea, and for UAN at least about half that, so 0.65 pounds of NBPT per ton UAN to meet. That's the minimum threshold. So any product that, if you follow the label, that has at least this amount of active ingredient will end up on our accepted list. And so looking at a number of products, this is not a complete product. There are 50 or more products that I'm aware of containing NBPT out there. But what we've developed these lists with three columns. One is with acceptable products. So these are the trade names. Then we have the middle one is conditionally acceptable products with double S, I see, and not acceptable products over there in the last column. And so the intent of this is that a farmer can go back and look at this, that farms looking at putting on an inhibitor within that RISMA and can look at this and say, well, which ones of these products will be acceptable and which ones will not. And so that's really the guidance that this is intended to provide. This is a work in progress, I should say also. Again, there are many more products that we're looking at, but these are the products that we've heard from agronomists within the RISMAs are most commonly used, so we started with these. All right, so that was the urease inhibitors. Then for the nitrification inhibitors, we have been looking so far at nitropyrin and DCD. And we've done, and where these two products that work in, they are function somewhat at the same step within the nitrification process, that both nitropyrin and DCD inhibits this ammonia monooxygenase enzyme, which is the first step in the conversion from ammonia to nitrate. And so one added mechanism of nitropyrin is also it is what is called bacteriostatic, which means that it will inhibit the activity of the bacteria itself, of Nitrosomonas itself, and that further slows the process. But it's primarily this AMO enzyme that is being inhibited by these products. As the inhibition effects or impact of the products starts to diminish, well, then the process will accelerate. This is the bottleneck in the process of conversion of ammonia to nitrate. So, looking at nitropyrin, again, this is a product that has been around since 1970s. It is maybe the product that we have looked at that has most research data behind it. It has been looked at in studies everywhere in the world, including here in the US. And it has certainly shown that it is very effective. It inhibits, again, this AMO enzymes and has a bacteriostatic effect on Nitrosomonas. And there are studies, both at Nutrient Star that sort of has nationwide, and then Giles and Jeff and Piddlecove gets his first name, that did some work here, both here in Minnesota, and I think this one is from Illinois. So it certainly has proven that this active ingredient works. As for application rate, nitropyrin is a little different compared to the other products, is that there's only one company that sells it, a company called Teva. Because of there is so much research that there is an overwhelming evidence that if a farmer uses the application rates that's on the label, then they can expect the product to work. It's a pretty long list on the label. It varies by time of year, or application, time of year, to which crop and so forth. But we feel that the studies have shown that if a person follows the application rates that are specified on the label, you should expect that it works. And so therefore, our table for nitrification inhibitors containing nitropyrin is pretty simple. That the ones that are currently on the market, Instinct, a couple generations of that, and Insert, that they all work, and we will accept those. There are no conditionally or not acceptable products. So that's a product that we have high level of confidence in. As for DCD, that is a product. It has been around for a long time. I think people started looking at it over 100 years ago, and at first it contains quite a bit of nitrogen in and of itself, and so it was first intended to be a nitrogen fertilizer in and of itself. But then later, it was found to be toxic to plants at high rates, but it was also found that at lower rates, it acts as a nitrification inhibitor. There are a lot of studies that has looked at DCD also. Again, Nutrient Star, over 150 studies that looked at some work by Rod and Dave Franson up at NDSU as well. And so here also, again, yes, we have evidence, we have confidence that this product, this active ingredient is effective. When it comes to application rate, this is very difficult, or has been more difficult to determine a particular application rate. And so we were looking back at for a couple of reasons. One is, well, if it is formulated into the prill, so the urea prill itself, such as the product called Super U, where it's actually blended in when that fertilizer is manufactured, then it's more effective compared to if it is added, as a coating later. Also, Dave Franson up at NDSU said, well, you really have DCD should really be more than 1% of the total amount of nitrogen that needs protection. But if we talk about urea, if you add that much DCD in the current formulations, it gets sloppy. There's too much liquid added to the urea. And so we found some other studies, some from Europe and elsewhere, that sort of suggested some lower rates. And we were looking at, well, what are some of the studies here from the University of Minnesota? What have they shown? So it led us to develop a table, and this is one we are still working on actively, of the products that are out there containing DCD that meets the requirements. So I see that we want to make sure people use it as labeled. So it listed twice there, I see. Regardless, we have 5 products currently that are in the acceptable range, and then we have one Excelis Max that just has too little of that active ingredient to be effective. So therefore, that will not be, we did not consider that to be an effective product. All right, so that was really where we are at relative to inhibitors. Again, we have a document developed. We're about to publish it on our website. There's more, if anyone is interested in more information about inhibitors and PCUs, Alan Blaylock gave an excellent presentation last year at the Nitrate conference up in St. Cloud. And so here's a link to that presentation. Dave Franson has a great extensive publication, Dave Franson of NDSU, called Nitrogen Extenders and Additives. And then, of course, here at the extension here at the U of M, a lot of excellent information also related to nitrogen. All right, so that was what I had on inhibitors. Now I just have a couple of slides about the Ag Weather Network. So now shifting gears entirely, completely different, nothing to do with inhibitors. 3 years ago, we had Ag weather stations located in different parts of Minnesota. But there were different organizations that had put them in. For example, North Dakota's Ag Weather Network, or NDON, they had put in, 35 stations in northwestern Minnesota. Department of Ag, we had put in 14 weather stations in central Minnesota, and the University of Minnesota had weather stations at the research and outreach centers. So there's a couple in southern Minnesota, one in Morris in western Minnesota, and then up at Crookston in northwestern Minnesota. And at a few other stations across the state as well. But it was sort of a little bit of unfortunate that, because if a person wanted access to that weather data, you needed to know where that weather station was, and you needed to know who do I call to get the information. Because if you could easily be in a situation you need to call both the university and MGA and NDON to get data from within a geographic area. With support from, we'll see how long this goes, with support from the commodity groups and other organizations in Minnesota, at the Department of Ag, we received funding from the Clean Water Funds to do 2 things. One was to try and combine those weather networks, so at least that the data would be available from one location and make it much more accessible. So that's one thing. And the other thing would be to expand the network to have a statewide coverage of these weather stations. And so where we at now, it's shown a map over there on the right. The counties in green, of course, that's a map of Minnesota. We just cut off the arrowhead up here. But the green counties, green shaded areas, those are the counties that, where we have most of the row crop agriculture in the state. And that is the area we hope to cover with weather stations. A weather station, we typically consider that to be representative for a radius of about 20 miles around the weather station itself. And so on the map there, there are some little figures and then a lighter bluish circle around it. And so all the red triangles, those are weather stations that the folks from North Dakota have put in. So they're primarily in northwestern Minnesota. So they put them in over a decade ago. Then all the blue circles, those were the ones the Department of Ag had put in. also about 10 years ago. And then the yellow squares, those are the new weather stations that we started putting in. You'll notice that before we started this expansion, we had a good coverage in northwestern and central Minnesota, but the southern third of the state, anyway, had very little coverage. And so we installed 9 new weather stations last year. We have put in 14 new ones this year, and we have another 4 to go for this year. And then we hope over the next 3 years, we're going to put in another 40 stations. So against the ones we put in last year and this year are all the ones in with the yellow squares there. You will notice that one of the first things we did, and I'm really excited about this, but I think, like I said, we at MDA are really excited about this, is that we had a great collaboration here with the university, so that the first weather stations we put in were at the University Research and Outreach Center. So Waseca, Lamberton, Morris, and up in Crookston, so that that these weather stations already start collecting data, reporting data, so that whenever you all are out doing research, that you will have access to that data. And also that if you're then developing apps or tools or other guidance for farmers to use, well, that since once the network is all built out, you've had kind of a 3 or 4 year head start on doing the research, using the weather data as needed, if you need that for the apps or the tools, so that it's ready to roll out once we have the network completed. All the data from when we set up this network, we're looking around. Well, the biggest decision perhaps was what do we do with the data? How do we make all the data available? And so after our discussion, we went with the North Dakota Ag Weather Network. So we're collaborating with NDON at NDSU. They already had a little over 100 weather stations in North Dakota. And so they already had a website, a database, and a mechanism to make the data available on their website. And so we're collaborating with NDON. So all the data from the Minnesota stations are available through NDON's website. I just listed it right there. It's available at no cost. Data is transferred from the weather stations every 5 minutes, and is then loaded up to the website. There are some maps showing the current weather conditions, and then all the data is available for download. Again, all at no cost. The weather stations we put in are towers, 10 meters or 33 feet tall. We measure temperature and humidity at 10 meters and at 3 meters. Wind also 10 meters and at 3 meters. And then we, other than that, we have, wind direction, wind speed at 3 meters, 10 meters, deep soil temperature and soil moisture. We measure soil temperature at 20 centimeter increments down to 7 feet. And soil moisture sensors at 5, 10, 20, 50, and 100 centimeters. We have soil temperature under turf and bare soil at 4 inches also. Solar radiation and all season precip gauges, so we can measure both liquid and solid precip, so rain and snow and hail and all that. The data from that it is a bit the raw data or the hourly, daily, weekly, monthly, annual data is available for anyone who would like to download it, but the data is also used and integrated into a number of tools and applications that are available mostly from NDON. So there's various NDON crop modeling, estimation of daily evapotranspiration or crop water use, air temperature inversion. That is something that is used for an app for spraying of herbicides to determine if there's risk of revolatilization and drift of herbicides. Calculates growing degree days for a number of different crops, various disease risk modeling, blight, potato blight, rust, cercospora, and sugar beets and others. And then a new one that just come in for North Dakota is a cattle comfort index based on temperature and humidity as well. And there are a number of other apps and tools available. And so really the main purpose here is to make weather data available in areas, especially rural areas of the state that might not otherwise have access to local data. And both for farmers to use some of the applications I was talking about, but we're also seeing a lot of it for weather emergency applications, such as when you have windstorms, hail, or the like. A lot of crop adjusters are using it too. And so we're seeing a lot of risks of flooding and so forth. Or there's some of the uses that are listed there. But again, really one of the primary ones are to use by farmers to make decisions about their production. Another thing we have cameras on most of the stations as well. Take a new picture every day. And they're all loaded onto the website as well. So if anyone wants to take a look at, you have a site or research at Wasika, and you're wondering, well, what might that look like? Are the general conditions? How much snow did they get last night, for example? Well, then there's a picture of snow depth. We have some staff gauges, not for water, but for snow depth, that is within field of view of some of the camera angles, so a person can go in there and see, well, how much snow fell the night before, for example. Or if you just want to take a general look at what are the weather conditions in Wasika right now, well, you can look at the data, or you can look at the picture. All right, so I talked about the need for the nitrogen fertilizer, of adopting nitrogen fertilizer BMPs, especially in Drismas that have high level of nitrate in the groundwater, to help reduce nitrate leaching losses and protecting that groundwater resource for drinking water. Then I talked about that some of those BMPs relates to the use of CPUs or inhibitors, and that we have gone through a process of determining which inhibitors and PCU ESN that meets the requirements that farmers can use, both for them getting value for the money they're paying, but also for groundwater protection. And then I ended on just giving a brief overview of the ag. So Anna, that was what I had. Take questions if there are any.
I have a question regarding weather stations.
Yes.
So the 14 that you already installed, is the data available online now? And now?
Should I repeat the question for the online folks?
Sure.
So Vasu was asking if the weather, it was about the weather station networks, if the weather data from the stations that were installed this year, if that's already being reported to the website. Yes. When we install the weather stations, it typically takes 2 half days to do. When we're done on the second day, we turn on the modem, and we're coordinating with Endon ahead of time, so they are ready to accept the data into the database. And we flip on the modem when we're done with the install on the second day, and it starts transmitting data right away. So data is recorded from the day we finalize the install. So yes, all the data from those 14 stations are available. Yeah.
So I know in the past, the Minnesota Ag Weather Network was, so we chose the area as like well-watered grass so that we can use those data sets for ED calculations. Are the new ones also put in standard conditions?
Excellent question. So Vasu is following up with a question about the location of where the weather stations are put in, if they meet the general standards requirements for agricultural weather stations, especially in terms of evapotranspiration calculation. Yes, and that is one of the things that we are we pay most attention to, is the location that of the station. We want to make sure that it is it's representative for the area that it's covering, so that if it's an area with irrigation, we want it adjacent or among irrigated fields, so that the air mass we are measuring is representative for the agriculture in the area. And of course, it also means away from buildings and fence rows and berms and roadways and large lakes and parking lots and all that kind of stuff. As for the surface cover, the arrangement we make with the landowners are typically that they will help mow the grass and such, but and if they don't do it, we will do it, and we typically do that 3 or 4 times a year. And so it's not always the 10 centimeter grass that is in the FAO 56 publication and all that stuff. But we think that because we're in Minnesota, we are almost always going to be under reference conditions for that site, unless if we have very dry situation. So we think we're in reference conditions, and also because we are monitoring wind speed, especially at 3 meters instead of the standard 2 meters. That means that even though that maybe the surface vegetation is a little bit longer, a little rougher, that because we are measuring a meter above, that we are less impacted by that, and then you can always use the the logarithmic wind function to adjust it down to 2 meters. And so so for that reason, we also have a couple of locations. For example, Sika is a good example where it's actually a fence around it. We have a couple of locations where they are located in cattle pastures, where we have horse panels around it to kind of exclude livestock. And so, of course, that might also have a slight impact on wind speed. But again, because that anemometer is at 3 meters, it shouldn't have too much of an impact. And if we need to, we can go to, I use the wind speed anemometer at 10 meters and use that to adjust the wind speed. Sorry, that got very detailed. Yes.
Hi, Ava. Thank you for the presentation. I have a question regarding the stabilizers. So does MDA take into account if these products or part of these products will end up in the edible parts of the plants or in the water bodies before making recommendations, or there is no evidence you can eat well?
That's a great question. So the question is if when we look at these inhibitors and make the evaluation, if we look at the risk of the active ingredient of ending up whether in the plant or in water or the off-target places as well, we do not. We have only to the extent that we have, when we look at the data and we look at the safety data sheets for the products, that we ensure that there isn't anything like that's has been documented to be toxic. Of course, toxicity is always about the dose and such, but we look at the safety data sheets, but other than that, we do not consider whether or not it might end up in the plant or the edible parts. Yeah, great question. Yeah, Carl.
So nitrifying is you have to register that with
Yep.
EPA,
Yep.
so they have to go through that process of determining whether it's going to be
Yes.
the edible part.
Yep.
When I first came here, I did a trial for a cow on sweet corn where they looked at it. And I know that nitrifying is recently registered on potatoes, so I assume that they had to get it registered, they have to go through that process.
Yep.
The difference is DCD is sold as a fertilizer, not as an inhibitor really. So they don't have to get that registered. So I don't know how that.
Yeah, well, and it's also because nitropyrin is considered a restricted use pesticide. And that's why it has to go through the, and I think pronitrogen is too. Pronitrogen?
Yeah,
No, I'm not sure about that one. But that's why that nitropyrin has to go through the whole EPA thing, because it is a pesticide, and they have to report their sales as a pesticide, whereas NBPT and DCD are not. Also, these inhibitors fall, now I'm getting a little in the weeds as well, but they fall a little bit in a gray area in that there are, when we talk about pesticides, such as nitropyrin, they have to be registered with the EPA, their sales has to be reported to the state. And so we have a really good, and there's a big, like an approval process for those products. Same for fertilizers and certain plant amendments. They also are registered at the state and they have to, there's some approval process. Inhibitors, other than nitropyrin, falls between the two. So that means that there's not really any regulations here in Minnesota related to inhibitors, except if a DCD is sold as a fertilizer. But a lot of the DCD products are not. The companies are labeling them as an inhibitor because then there's really no restrictions. Also, when you sell fertilizers and pesticides, as a seller, you have to pay a fee or a tax to the state. For inhibitors, since they're not regulated, there's no tax. We know there is a private label company here in Minnesota that were telling us that they, like for DCD, that they can sell it as private label primarily for independent co-ops or individual co-ops, and they have over 50 products containing DCD that is on the market in Minnesota, and that's just on the private label side. So there are a lot of them.
For the PCU, you guys have any ongoing research study about microplastics or biodegradable food?
Yeah, so the question is about PCUs, if we have any ongoing research related to microplastics or biodegradable coatings. That's a great question. The short answer is we don't have any research going on that specifically. But we are very much looking to the research that's taking place here at the university, not least some of the work that Fabian, I think is funded by AFREC, isn't it? Oh, are you working on that? Oh, well, you know more about it than I do then. So that is something that we are very interested in looking at. I will say we primarily look at it from a fertilizer, the nitrogen protection standpoint. But as you know, a couple of years ago, there were at the legislative level some discussions about microplastics and potentially banning uses of polymers such as those used for ESN, for example. It didn't go anywhere, but at that time, but it certainly could come back, and of course that's something we're watching, and also very much watching what's going on in the research both here at U of M, Iowa State, elsewhere, where they're looking at biodegradable polymers. Excellent question. Right.
I was just wondering, in the NOR space, whenever you use nitrification, they have to be registered to commercially apply pesticides. And that's been an issue because a lot of the NOR haulers are not commercially licensed to apply pesticides. Are you seeing the fertilizer side too, or is it mostly co-ops applying the fertilizer they already have?
Yeah. We haven't really seen that, but also because you don't need a commercial license to apply fertilizer. Yes.
So the fertilizer.
Oh, I see. Oh, yeah. That's a good question. Actually, I haven't heard that come up. That's a very good point. That's a good point. Yeah, good point. Thanks, Liz, for bringing that up.
I have just a question philosophically about, as you're looking at research to make policy, how often are you finding big gaps in what you need to know for policy from the published scientific literature? Is there like a lane that those gaps kind of fall into, a category that those gaps fall into? It looks frustrating.
Yeah. So Anna is asking if, when we look at it from a policy standpoint, and we need to have policy being informed by research, if we ever run into that there's not enough research out there. I guess the short answer is absolutely all the time. We are a science-based organization, and we want, whenever there's policy taking place, and I do have to say that my job, I work as a scientist, as a technical person, and so I might provide technical information to inform policy, but I'm not the one forming the policy itself. That's at a higher level, way above me. But regardless, I'm the one that have to dig out what there is of research, what does the data show. And I think almost always I'm scrambling a little bit to find, well, what research is available, what's out there. Both because often it is quite specific what I need to look for. For example, one example is when I talk about inhibitors with DCD. Why haven't anyone established and published a minimum rate of DCD? I know the answer, because it's really difficult to do, because there's so much many factors that impacts that. But researchers sort of daring to stick their head out a little bit and make maybe a little more bold statements like that would be very helpful. No, and I'm saying this sort of that tongue in cheek. I very much understand. I have a background in research myself, and I very much understand that no, you can't factor all or account for all factors when you do your research. You always want to make sure that you make clear under which condition or circumstances that a given research results are valid under. The problem I have now is that I need to be the one that takes that data and try to extrapolate that to like across other like soil types, weather conditions, and such. And so more research. Right. Yeah. No. And often they want a yes or no. Like, is it above or beyond, or what's the threshold? And of course, we all know most things we work with it depends. Yeah.
That's good. Go on another one.
Yeah, so why, same line of thought, like, when do you feel, ask this question, like, under what circumstances do you feel like you have robust data to answer a question like the scope, the types of measurements, the geographic range? Like, when do you feel like, I feel very confident saying yes or no to my statements?
Yeah, great question. So the question is, when do I have enough data to be confident in and say,
much more concise way of
yeah,
asking that question.
that's a great question. Usually what I need to do is looking at things from say a statewide perspective, so that whatever some policy may be considered, what might the statewide impacts be, and often so I can find information about research at Wasika or caustics of soils at Becker or something like that, which is really helpful. But having, like, one thing is if studies are repeated at multiple locations in the state is very helpful. Again, such as some of the ESN work that's currently taking place, or that's been a lot of like nitrogen fertilizer trials and other things, that is very helpful to be able to point to that, sort of say, well, there are some differences across the state, because otherwise, if it's at one location or two locations, well, then we have to extrapolate from, say, southern Minnesota to central sandier soils or northwestern Minnesota, where we know that, well, the soils are different, or the northwest, less rainfall and different soils and everything. So multi-location, multi-year studies, and really like good old-fashioned solid research, with 3 or 4 reps and all that stuff is the best.
Okay, we should wrap up. Thank you, everybody, for letting us go a little later to account for my technical difficulties along the way. And thank you again, Jeppe.
No, thank you. Thanks for having me. And certainly, if there are any questions or follow-ups or ideas or something along the way, definitely let me know. One thing I also just want to leave you with is that back to this discussion here at the end, that we do fund quite a bit of research here at the university, either directly from the department, and there's AFRAC, if you're familiar with that. But even outside of AFRAC and current research, we are always interested in good ideas related to primarily nitrogen fertilizer management. So any ideas that anyone may have, don't hesitate to bring them to us. We might not always be able to fund it, but we do have had several times in the past where we have been able to help out. So don't hesitate to bring any ideas to us if you have them. Thank you. Really appreciate the questions. Appreciate the discussion. Again, if you have any questions, let me know.
Thank you.
Oh, thank you.
I have some notes.